The handle system is a technology specification for assigning, managing, and resolving persistent identifiers for digital objects and other resources on the Internet. The protocols specified enable a distributed computer system to store identifiers of digital resources and resolve those handles into the information necessary to locate, access, and otherwise make use of the resources. That information can be changed as needed to reflect the current state and/or location of the identified resource without changing the handle. The handle system was developed by Bob Kahn, co-inventor of the TCP/IP protocols that underlie the operation of the Internet, with support from the Defense Advanced Research Projects Agency DARPA at the Corporation for National Research Initiatives, which continues to develop and manage it. The handle system is currently in use in several applications. The handle system enables management of objects as first-class entities, rather than as packets of bits with dependency on other attributes such as locations. It emerged as part of a wider framework for distributed digital object services but has been used in independent applications. The system is designed to be scalable to very large numbers of entities without performance degradation, to allow distributed administration, and to enable resolution to multiple pieces of current data. It also has further optional features such as public key infrastructure capability to enable trust applications. Resolution is the process in which an identifier is the input request to a network service to receive in return a specific output of one or more pieces of current information related to the identified entity, e.g., a location. The domain name system resolves domain names meaningful to humans into numerical IP addresses. The handle system is compatible with DNS but does not necessarily require it. Unlike persistent identifiers such as PULs or ARCs, which utilize domain names and therefore ultimately constrained by them, other significant differences include the administrative granularity possible with the handle system and the option for extensible multiple data types to be assigned. DNS has well-recognized problems of security and updating which suggest that it will not be sufficient to assume that existing DNS technology can simply be adapted to deal with new requirements. By explicitly separating names from all associated data, including location, the handle system addresses a key requirement of future Internet architecture. A joint research project by the MIT Laboratory for Computer Science and Air Force Research Laboratory argued that it is possible to separate the ideas of location and identity, both of which are represented by the IP address in today's Internet. The resulting architecture facilitates mobility as well as solving other problems with today's network. Specifications. The handle system is defined in Informational RFCs 3650, 3651 and 3652 of the Internet Engineering Task Force. It includes an open set of protocols, a namespace, and a reference implementation of the protocols. Handles resolve to typed data. Documentation, software, and related information is provided by CNRI on a dedicated website. Each handle may have its own administrator, and administration of these handles can be done in a distributed environment. The name-to-value bindings may also be secured, both via signatures to verify the data and via challenge response to verify the transmission of the data, allowing handles to be used in trust management applications. The syntax of the handle encompasses any Unicode character and leaves the string construction to the assigner. The implementation of the handle system consists of local handle services, each of which is made up of one or more sites that provide the servers that store specific handles. The Global Handle Registry is a unique local handle service which stores information information on the prefixes within the handle system and can be queried to find out where specific handles are stored on other local handle services within this distributed system. Handles can be used natively or expressed as uniform resource names, uniform resource identifiers. Although the handle system is not currently a registered standalone implementation of URI or EARN, it is a part of the Info-URI specification, RFC 4452. Handles may also be expressed as uniform resource locators by the use of a HTTP proxy server implementation. The handle system website provides a series of implementation tools, notably the handle.Net software and handle.Net client libraries. Handle clients can be embedded in end-user software or in server software, and extensions are already available for Adobe Acrobat and Firefox. Handle client software libraries are available in both C and Java. Some applications have developed specific add-on tools, e.g., for the DOI system, the interoperable network of distributed handle resolver servers linked through a global resolver. Users of handle system technology obtain a handle prefix created in the global handle registry. The global handle registry maintains and resolves the prefixes of locally maintained handle services. Any local handle service can, therefore, resolve any handle through the global resolver. Handles are passed by a client as a query of the naming authority prefix to the handle system's global handle registry. The GHR responds by sending the client the location information for the relevant local handle service. A query is then sent to the relevant server within the local handle service. The local handle service returns the information needed to acquire the resource, e.g., a URL, which can then be turned into an HTTP redirect. Though the original model from which the handle system derives dealt with management of digital objects, the handle system does not mandate any particular model of relationships between the identified entities, nor is it limited to identifying only digital objects. Non-digital entities may be represented as a corresponding digital object for the purposes of digital object management. Some care is needed in the definition of such objects and how they relate to non-digital entities. There are established models that can aid in such definitions. See IDOC-CRM and Index Content Model. Some applications have found it helpful to marry such a framework to the handle application. For example, the Advanced Distributed Learning Initiative brings together handle system application with existing standards for distributed learning content, using a shareable content object reference model, and the digital object identifier system implementation of the handle system has adopted it together with the index framework to deal with semantic interoperability. The handle system also makes explicit the importance of organizational commitment to a persistent identifier scheme, but does not mandate one model for ensuring such commitment. Individual applications may choose to establish their own sets of rules and social infrastructure to ensure persistence. Design principles. The handle system is designed to meet the following requirements to contribute to persistence. The identifier string is not based on any changeable attributes of the entity, is opaque, is unique within the system, has optional but nice-to-have features that should be supported. The identifier resolution mechanism is reliable, is scalable, is flexible, is trusted, builds on open architecture, is transparent. Applications. Among the objects that are currently identified by handles are journal articles, technical reports, books, theses and dissertations, government documents, metadata, distributed learning content, and datasets. Handles are being used in digital watermarking applications, grid applications, repositories, and more. Although individual users may download and use the handle.Net software other independently. Many users have found it beneficial to collaborate in developing applications in a federation, using common policy or additional technology to provide shared services. As one of the first persistent identifier schemes, the handle system has been widely adopted by public and private institutions and proven over several years. Handle system applications may use handles as simple persistent identifiers, or may choose to take advantage of other features. Its support for the simultaneous return as output of multiple pieces of current information related to the object in defined data structures enables priorities to be established for the order in which the multiple resolutions will be used. Handles can, therefore, resolve to different digital versions of the same content, to mirror sites, or to different business models. They can also resolve to different digital versions of differing content, such as a mix of objects required for a distance learning course. There are thousands of handle services running today, located in 71 countries, on 6 continents. Over 1,000 of them run at universities and libraries. Handle services are being run by user federations, national laboratories, universities, computing centers, libraries, government agencies, contractors, corporations, and research groups. Major publishers use the handle system for persistent identification of commercially traded and open-access content through its implementation with the Digital Object Identifier system. The number of prefixes which allow users to assign handles is growing and stands at over 12,000 as of early 2014. There are 6 top-level global handle registry servers that receive 68 million resolution requests per month. Proxy servers known to CNRI passing requests to the system on the web receive 200 million resolution requests per month. CNRI and ITU recently entered into an agreement to collaborate on use of the handle system and are working on the specific details of that collaboration. In April 2009, ITU listed the handle system as an emerging trend. Licenses and use policy. Handle system, handle.Net and Global Handle Registry are trademarks of the Corporation for National Research Initiatives, a non-profit research and development corporation in the USA. The handle system is the subject of patents by CNRI, which licenses its handle system technology through public license, similar to an open-source license, in order to enable broader use of the technology. Handle system infrastructure is supported by prefix registration and service fees, with the majority coming from single prefix holders. The largest current single contributor is the International DOI Foundation. The public license allows commercial and non-commercial use at low cost of both its patented technology and the reference implementation of the software, and allows the software to be freely embedded in other systems and products. A service agreement is also available for users who intend to provide identifier and/or resolution services using the handle system technology under the handle system public license. Related technologies. The handle system is the first piece of a long-term digital object architecture. In January 2010, CNRI released its general-purpose digital object repository software, which is the second major component of this architecture. More information about the release, including protocol specification, source code and ready-to-use system, clients and utilities, is available. The third and final piece, the digital object registry, will be released shortly. The continued use and evolution of the handle system is in no way dependent on these other components, but those already using handles may find them useful in small or large ways, and both are, or soon will be, freely available under an open-source style license.